Hello, my name is Sheyi Fabi. I've come again on your GIS lecture series. Today we are considering GIS lecture series 8, and we are going to look at image analysis, and we shall use IDRISI as our. We're going to use IDRISI as our software to use to look at different form of image analysis. Today we look at two techniques and how to use it, what we use it for, and how we can do it in the IDRISI environment. We are going to look at the image scalar, and we are also going to look at image regression. These are like image scalar is an algebraic technique that we use in image analysis. You can use it to derive another image from a given image. For instance, if you get a land use map, if you know the relationship between the land use map and the soil fertility, you can derive soil fertility map from the land use map. We use this when we have data gaps. For instance, you want to do a trend analysis of the land use and soil fertility, and you notice that there are some data gaps within the period for soil fertility. You can look at the relationship between the data sets available between the land use and the soil, so that you can use that one to derive images of soil for the intervening period within the period. And then image regression is like regression analysis. You want to look at the relationship between two images. They must be image of the same area, but they may be the land use. For instance, we have the land use map of Ibadan in 1986, and you have the land use map of Ibadan in 1996. You can do image regression. When you do image regression analysis for the two period, this one can show you the relationship between the changes that is taking place there. Or if you have the temperature map and the relief map, you may want to look at the relationship between the temperature of a place and the relief. Or you may want to look at the rainfall and pressure, the pressure and the rainfall at a given time. So if you have the maps, if you have the images of the two period, and then you can do the kind of analysis, regression analysis. So we are going to quickly look at how you can use it, what you can do with it in the IDRISI environment. So we take us to IDRISI environment. By now we are familiar with what we have in IDRISI. IDRISI interface, we have my previous lecture, I've looked at it that I've shown us the interface of IDRISI. And today we are not going to look at the interface per se. We want to look at how you can use the images to do some form of analysis. The first thing we want to do is that they want to look at the relationships. We want to regress one image to another. And we're going to use the example of a place in Kenya, Nakuru district. It's an area that is very hilly, and it has want to look at the relationship between the elevation and the rainfall. This is the image of the elevation, that is the relief of the place. And here, what we mean is that each of the pixels here represent a value of relief. This is 616 in feet. This is the relief in the area. You can see different type of relief. And this one represents the rainfall of the place. So, and this is the rainfall in millimeter per annum. Mean annual rainfall per annum. So you can actually look at the relationship between this image and this image, so that we can say for the specific area, there is a relationship between the elevation and the rainfall. A sort of relief rainfall, convective rainfall can actually be related to the relief, the elevation, because the higher places have some form of convective intervention in the rainfall. So if you have these images, then you can go to mathematical operator and statistical operator. You go to regress. Regress means you want to do regression analysis, and regression analysis you can do linear, or you can do multiple regression analysis. In the case that you want to look at the soil fertility, let's say you have the image of the soil fertility, and you want to look at the variables that contribute to the value of the fertility. You want to look at the rainfall, you want to look at the temperature, you want to look at the land use. So when you look at all this one, how do they contribute to the fertility? So you can have multiple regression. But in this case, we don't want to look at the linear relationship between two images, and that is the elevation and the rainfall. So what we do is that you pick the independent variable. With the normal conventional statistics, the independent variable is the one that is independent, that is actually determined, that is being determined by the dependent variables. We want to check whether the amount of rainfall that falls in this region is influenced by the elevation, by the height, by the topography. So therefore, the independent variables will be the annual rainfall. We want to check whether the amount of rainfall that is falling, that falls in an area, is actually in this area, this specific area, because the relationship may not be true for all areas. But we want to look at it that in this Nakuru district, in the northern Kenya, is the amount of rainfall dependent on the elevation. So our independent variable will be the annual rainfall. So you can get the annual rainfall from this. We have the N rain. N rain, that's where the data is located. The dependent variable is the relief. So you go to N relief. This data are available as part of the sample data for IDRISI. So you have to give it. You can put optional, then you have another image that you want to use it. And then another thing I want to show you is that you can actually regress image, or you regress the attribute data. When you are regressing the images, what you are doing is that you are using the pixel value as cases. The pixel value represents the cases, and then when you click OK, it gives you the relationship map. We are familiar with this kind of analysis, where you have the Y, which is the independent variable. Yes, is dependent on the X. Y is determined by the X. We have the Y is equal to A plus A is a constant plus bx, which where b is the component or the coefficient. So in this case now, we have y is equal to a plus bx, and the value of the coefficient. The beta value is 5.8, 98216, while the r, the coefficient of determination, the R scale value is the R scale value, the R value is 0.6, which is the correlation coefficient, whereas the coefficient of determination is 46%. That means the 46% of the amount of rainfall in that area can be determined by the elevation in that particular, but that relationship is only true for that area. It cannot be generalized for relationship between relief and rainfall. That shows that in this area, significance of the rainfall in the area in the Nakuru district is more of a convective rainfall, is by convention. So that means you can actually use this image, the image of relief, to derive the image of rainfall. So if you have in the subsequent, let's say you are looking at a time series of every 5 years, but you don't have the information for relief for every 5 years, but you could get the information for the rainfall every 5 years. You can actually derive the relief from the elevation using the scalar. So actually the scalar and regress are always used together. So now we have seen the relationship between these two images, that is the elevation and the rainfall. We can actually go for scalar to derive what is the relationship between the how can we derive the image of rainfall from the elevation, because our elevation is x and our rainfall is y. So if you want to do that, what we are supposed to do is to multiply relief by this value, this constant, and add it to this to get the image. How we do it is to go through scalar. We go to IDRISI analysis, mathematical operator, and scalar. So now we want to derive the image of the rainfall from the elevation using the constant that we have observed in this analysis, regression analysis. So you put input image. Our input image is now the elevation, N relief, and then the output image, we just say rainfall 1, because it's not yet the rain, let's call it rain 1 because it's not the final data. And what we want to do is to multiply it by this to create an image of 5.089 82216x. So what is the scalar value that I want to put there? I'm going to put 5.89 8216. So what do we want to do with it? We want to multiply because it is 5 multiplied by x. So it's going to be multiplication. And then you will click this. Okay. So it's going to give us the rain 1. Rain 1 is this. That is the image of rainfall, which was derived from the image of the elevation. We multiply by this. So we have not finished yet. We still need to add this value to rain 1. So we go to, now our rain 1 has been saved here. Rain 1 is our rain 1. So our output image is rain. We are going to put it as rain F, which is rain final, rainfall F. But here, what we are going to add to it is now 1706.43, and it's going to be add. We are adding. The other one we multiplied, but this one we are adding. So when we add, going to give us this image. And we see that this image of rainfall rainfall is actually close to the image, the initial image, the original image of Nakuru district. We are going to open it and compare the two images, which is N rain. Yeah. So you can see the difference between this and this. So it is not complete the same, because we said earlier on that you can only explain 46% of rainfall by the relief. So the error level is still a little bit high. So that is how you can derive the image of you can derive the image of soil fertility from the image of land use. You can derive the image of pressure from the image of temperature. Especially, we use this one, especially when you are doing research and you have data gap. You have gaps in the data, you have void in the data, and you want to estimate the such image so that you can allow you to do trend analysis. I hope you enjoy this lecture. Next lecture, we are going to look at some other types of image analysis. Thank you for watching.